Very good morning, students. So today we will discuss very interesting topic of physics, that is electrostatics. And in electrostatics we will discuss about electric dipole. So starting with electric dipole. So let us first concentrate on the definition of electric dipole. What is electric dipole? Electric dipole is a pair of equal and opposite point charges. It is a pair of equal and opposite point charges separated by some small distance. So electric dipole is nothing but a pair of equal and opposite charges, point charges separated by some small distance. So basically it is a combination or system of 2 point charges. Is that clear? Here it is. Suppose this is minus q point charge and another one is situated at some small distance, that is 2a. 2a is a very small distance and these two charges are separated by 2a. This is the center of the dipole. This is A. What are the practical examples of electric dipole? So practical examples of electric dipole are just like some atoms and molecules of like CO2, HCl, ammonia, alcohol, and H2O, etc. Let us draw a very simple structure of H2O to understand how this H2O molecule shows electric dipole behavior. This HO, this is around 105 degree. This is H2O molecule. The charge distribution, the centers of the positive and negative charge distribution are separated by some small distance in H2O molecule. Here in this side, this is positive side, positive charge, and this side is negative side, separated by some small distance. So H2O molecule shows electric dipole behavior. Is that clear? Okay. Now moving to the next topic, that is electric dipole moment. Electric dipole moment. So what is electric dipole moment? Electric dipole moment, it is denoted by capital P. Electric dipole moment is nothing but it is a measure of strength of electric dipole. It is a measure of strength of electric dipole. Whenever we have to measure the strength of electric dipole, we need to find out the electric dipole moment. Yes, it is a vector quantity. It is a vector quantity because it has magnitude as well as direction. But if I talk about the magnitude of electric dipole moment, so magnitude of electric dipole moment is the product of, I repeat, is the product of magnitude of either charges and the distance of separation between charges. So, according to the definition of electric dipole moment, the magnitude of dipole moment can be written as Q, magnitude of either charges, into distance of separation. This is the magnitude of electric dipole moment. What is its SI unit? Its SI unit is Q. The SI unit of charge is coulomb and the SI unit of distance is meter. So SI unit of electric dipole moment is coulomb meter. And what is its direction? It is always directed. It is always directed from minus charge to plus charge. It is always directed from minus charge to plus charge. So this is all about electric dipole moment. I hope all of you have understood the concept of electric dipole moment. Now, moving to the next topic related to electric dipole moment. In earlier classes we have studied that how to find out the electric field intensity at any point P due to the point charges, whether it is plus point charge or negative point charge. Similarly, in this case also, how can we find out the electric field intensity at any point P due to this electric dipole? So basically there are two cases, one for on an axial line and another one for equatorial line, and there is one more case also, that is general case. So let us start with the very first case, that is how to find out the electric field intensity at any point P on the axial line of an electric dipole. Electric field intensity on the axial line of electric dipole. So let us consider an electric dipole. Suppose this is minus q and this is plus q, separated by some small distance 2a. This is the center of the dipole. This is A, again this is A. Now we can produce this AB on either side, whether from B side or from A side. So this time we are producing AB this side. This is the axial line of electric dipole. Now let us consider any point P on the axial line and placed unit positive charge over here, and placed any unit positive charge over here on the axial line of this electric dipole. Now let us consider this point P is situated at a distance r from the center of the electric dipole. We always take distance from the center of the electric dipole. Now first of all, taking one by one, what is the field intensity, electric field intensity due to this minus q charge at point P individually? So let us consider E1. E1 is an electric field intensity at point P due to this minus q charge individually, and E2 is an electric field intensity at point P due to this plus q charge individually. As we know that the distance of separation from this plus q charge is less than that from minus q charge, so electric field intensity, that is E2, will be greater than that of E1. So because as we also know that electric field follows inverse square law, so here we can see that magnitude of E2 is greater than magnitude of E1. So net electric field at P will be equal to E equal to E2 minus E1. Right now, this time we are talking about only magnitude. And what about the distance? What about the direction? The direction, as we know that E2 is greater than E1, so the final direction, the resultant direction at point P is along BP and directed along BP in the direction of E2, as E2 is greater than E1. I think this is clear. I hope the concept is clear up to here. So going ahead, let us first find out the magnitude of E1 and E2 separately. So what is the magnitude of E1? 1 by 4 pi epsilon naught Q by R plus A. What is the distance of point P from minus Q? R plus A. So according to Coulomb's law, this is R plus A whole square. And what is E2? 1 by 4 pi epsilon naught Q R minus A. Distance of point P from plus Q R minus A whole square. Now by putting these values of from 1 and 2 in this mathematical expression, we will get the final resultant electric field at point P. Okay, I hope all of you have noted down the above portion. So shall I rub the above portion? Okay. The magnitude of resultant electric field at point P will be equal to E2 minus E1. So by putting these two values, 1 by 4 pi epsilon naught Q by R minus A whole square minus 1 by 4 pi epsilon naught Q by R plus A whole square. We are talking about magnitude only because we have already discussed about the direction and it is along BP. That means in the E2 direction, along the E2 direction. So by taking common, Q by 4 pi epsilon naught 1 by R minus A whole square minus 1 by R plus A whole square. Now the next step, by taking LCM, R minus A whole square, R plus A whole square, here it is R plus A whole square minus R minus A whole square. So in numerator section, what we should do? In numerator section, we can expand A plus B whole square identity and A minus B whole square identity. And in denominator part, we can apply this identity. A plus B into A minus B, that is A square minus B square. So we can apply this identity in the denominator part. Now, by applying these two identities, we can get this result. A square B square 2AB. Yes. A square B square 2AB. And here A square minus B square whole square. These two terms will be cancelled out and we will get Q by 4 pi epsilon naught 4 RA divided by R square minus A square whole square electric field. Now by rearranging the numerator term, Q into 2A into 2R and what is denominator term? 4 pi epsilon naught R square minus A square whole square. What is this Q into 2A? This is the magnitude of the dipole moment. So this is the magnitude of the dipole moment into 2R divided by 4 pi epsilon naught R square minus A square whole square. So this is the final expression of electric field intensity, resultant electric field intensity at point P. Now, by taking some consideration, let us consider one very common case, that is if R is very greater than the distance of separation between the charges. If the distance of the point P from the center of the dipole is very greater than the length of the dipole, so what will happen? We can ignore If 2a is less than r, that means a is also less than r. So we can neglect a, can be neglected. If a can be neglected, a square also can be neglected. So in the final result, if I apply this consideration, 4 pi epsilon naught r square minus 0 square, what will happen? 2r magnitude of p, 4 pi epsilon naught r4, 1 r will be cancelled out. So what we will get? We will get final result 2 magnitude of dipole moment 4 pi epsilon naught r cube. So this is the magnitude of electric field intensity. This is the magnitude of electric field intensity and directed along BP. All of you have understood. I hope all of you have understood up to here, and in next session we will discuss the next concept, that is what is the electric field intensity at any point P on the equatorial line of an electric dipole. So for today's, thank you so much.